All right, Assalamu alaikum guys. We're going to continue off of what we learned last lesson. So I showed you addition and subtraction of ordinates last week, but I'm just going to refresh. I'm just going to quickly go over it again. I just feel like we got to clarify a few things. Now, I've got, so the title is Sum and Product of Graphs, and I've got a number of examples to run through here with you. So let's go off of some of the rules that we remember. We're adding and we're going to be adding ordinates together. I'm also going to be showing how to multiply. There's a few rules for multiplication, but I think it's easiest if I just run through the graph with you and do it. Okay. Now, what it is really is you're just adding the y values. Okay. When you're dealing with the summing and producting graphs, you're dealing with the y values, and from those y values, you'll create the new y value. The x value just tells you how to line it up. Okay. So look at this first question. We are required to copy this graph below into our books and sketch the following graphs. So we have this, this, and this. Now let's start off with A, and let's add these two graphs. And I've got this pre-prepared here. And we're just going to focus on what we're going to do. So as you can see, we've got this parabolic shape here. This is y equals fx. So keep that in mind. And then we've got this line here. This is y equals to gx. So as we witnessed in the classroom, we are going to be adding the ordinates. So watch how we do this. And what I like to do, I like to start from the easiest points. And this is probably the easiest point to start from. So if I add these two graphs, do you notice that y value for this line is 3, and for this line it's 3 as well. So essentially we're doing 3 plus 3 here, which equals to 6. That means that the dot in this line, or the point in this line, if I add these two graphs, will result in being here. Because 3 from the straight line plus 3 from the parabola, or the curved line, will equal to 6. As you can see, I just stacked them on top of each other to give you a visual idea. And that's where my first point goes. All right, remember, it's always just vertical adding. The other important points that you should be adding are anywhere where we intercept across the x-axis. These are probably the easiest ones to plot. So as you can see, the curve intersects right here, and then the straight line in the same x value for x equals 0 is up here. So if we look at it again, this is y equals 0, this is y equals 2. What is 0 plus 2? That's going to equal to 2. So that tells me that the next dot is right there. Okay, so that should be pretty straightforward and clear there. All right, so now let's move on to the next obvious point. So one of the key points that you should always try and have a look at are any sort of values that balance each other out. So for example, if we look here, this is on y equals 1. This here is on y equals -1, and they're in the same x value. So something unique happens here. So I've got the straight line at +1, and I've got the curve at -1. If I add this, what's 1 plus -1? We end up with 0. So what this tells me is that we have an intercept right there. Okay, so our shape is forming nicely here. But let's move on to the next point. If I look at this point here, do you notice that the two lines intersect, and they're intersecting on the x-axis? So what does that mean? Like, the y value of the straight line is 0, and the y value of the curve is also 0. So what's 0 plus 0? 0 plus 0 is 0, meaning it's intercepting here again. But how can that be? How can I have my graph intersecting so close in proximity here? Well, basically what that means, when I do eventually connect these dots, I will be connecting like this. We get a little dip underneath, just like that. That's what that implies. You can't have it go straight and then flat here. That's not a graph. Okay, so in this case, the realistic approach will be that it dips under, and then we'll draw the rest of it. All right, let's move on. So now let's look at the next point. So over here, we have a y value of 3. Over here, we have a y value of -1. Well, if we add 3 and -1, 3 plus -1, that equals to 2. So look at that. I know where that point is now. Okay, it's as simple as that, guys. You're just adding y values together. And if I were to take a guess, can't really predict where this is, but if you notice, we're getting a parabolic shape okay? And I can guess that using some symmetry that this value here will be 6, okay? And then from there we connect the dots. Make sure you dip slightly below. Actually, let's go from here. One more time. I'm just not getting the right curvature. That'll do. All right. So with that, you can see that the line does this slight dip underneath, and that's pretty consistent. If I'm adding this and the negative of that, then you can see that the parabola pulls down a bit further in this region, hence why it's pulled down a little bit more here. And that's that. That would be the resulting answer. Okay, so that's y equals fx plus gx. Let's move on to the next one. The next question asks us to sketch y equals fx minus gx. Now, as you may recall, I told you there's a little bit of a trick that I like to enforce here. I don't like subtracting graphs. It's a thing that I don't like to do. What I instead do is I add the negative of that graph. So even if I'm forced to, I will. Let me just fit that in a bit better. So even if I'm asked to do this, what I'll do is I'll actually sketch the negative of that graph. So if we look here at gx, we are going to sketch the negative of it. And what I'm going to do that in orange. All I have to do is take these y values and make them negative. So that's +2, so I'm going to put a dot at -2. I have this one here, that's enough. And since it's a straight line, I could probably sketch it from there. But just to make sure, this is -2. So on the same x value, it's going to be +2. So that's where the other dot will be. And then from here, I'm going to connect these. And there we go. I'll be adding the orange graph and this curve. Okay, why? Because this is now -gx. So y equals -gx. Like I said, I do not like to subtract this graph with this graph. It's something I can't do. Not necessarily I can't do it. I just feel it wastes more time if I try and subtract these two graphs. So what's a better approach, in my opinion, is adding the negative of that graph that you're subtracting. So this is the negative. See the orange line? This is the negative of this. Okay, so now let's try and focus on this and this. I know it's a bit tricky. Maybe if I trace it, it helps. I'll make this one purple. All right. So from there, let's look at some key points. Over here, we have +3. I think this is the first key point here. There's +3. This is actually -3. It's not marked, but that's definitely -3. If I add 3 and -3. So notice I'm not worrying about the minus anymore. I'm just straight doing 3 plus -3. So 3 plus -3 is 0. So that's my first point right there. All right, next to that, we have 0 and -2. So if I add 0 and -2, I get -2. So my dot ends up right there. And then over here, here's the next important point. We have -1 for both the lines. So the purple and the orange line are both -1. So if I do -1 plus -1, I actually end up down here at -2 as well. So this is a similar situation to the previous graph. I'm going to have a little dip below like this. All right, let's move on. Look here, we have the purple and orange line intersecting at the 0. So guess what? That just means we're at 0 because 0 plus 0 is 0. Over here we have 3 and 1. So 3 plus 1 is going to give us 4. So I can put a dot right up there. And then finally, just going to keep moving along. To help me with my drawing, I'm going to use some symmetry to find a point on the other side to continue. I believe that will be the point right there. Wait. Yep, that'll be it. Okay, so now from this, let's connect the dots. And there we go. So the green line is the resulting answer. All right, perfect. Let me make the other lines dotted so it doesn't obstruct our view. And there it is. Okay. And now finally, so multiplication. I haven't really shown you this, so pay careful attention. I'll write some notes here for you. So with multiplication, the most important one is numbers that multiply with 0, I think. But basically, you're just multiplying y values at the same time. But keep in mind the moments where you're multiplying by 0. So for example, these are the easiest points to plot. If I see anything with 0, I know straight away that they're going to, if I multiply that with that, then I'm going to have a dot right here at 0. Okay, so let's start with those. We have an intercept here. We have a 2 here. 2 times 0 will give us 0. Here, they're both 0. So 0 times 0 is 0. So that one's clear that we're going to have a 0 point there. So as our first note, if one of fx or gx intercepts the y-axis, or sorry, the x-axis, then fx times gx equals 0. And I'm pretty sure that's a given, like you can figure that out. Fx times gx equals 0. Okay, I'm pretty sure that's clear. All right, let's continue. The other important point to consider is when you have positive numbers multiplying together. So for example, if you notice, everything here is positive. Everything here is positive, meaning if I multiply any part of this part of the graph, it's going to be above the x-axis. But if you notice here, this is negative and that's positive. What's a negative times a positive? A negative. So we're going to end up with results down here. Okay? And then also at the same time, this is positive and that's negative. So therefore, we're actually going to continue the trend with negative values. Okay, so that's a positive times a negative. We're going to have negative values for that. So let's start plotting in some more points. If we look here, this is 3 times 3, so that's actually quite high. That's 9, that's not going to fit in our graph. But essentially, I plot a point right there somewhere. So that's 9. All right, so we have like this drop like this. You can see that clearly from one point to the next. That's definitely going to be part of the graph. The next point after this 0 is 1. The x value is 1. So if I look here, I have 1 times negative 1. 1 times negative 1 is negative 1. So look at that. We can sort of see what's going on. We've got this happening, comes down to there, and then comes up to here. All right, how do we know that's going to happen? Easy, because the curve isn't going to do anything silly. It has to follow a path using a curved format. Okay? So now let's continue. We have 3 here times negative 1. That means we're going to end up at negative 3. So that means a dot right here. So some interesting things are happening. If I sketch, I should be able to sketch it now. But basically we're coming down from here, up here, and it looks like we touch this and then come down. Just like that. That's probably the graph. And with that, I will sketch this. All right, and then from here, we're going to sketch this part. A little bit tricky, just gotta be a little careful. And there we go. Just gonna rub that out, put arrows here. Put arrows here, and that's it. That's the graph of that one. So a couple notes there. If fx and gx or if fx greater than 0, gx greater than 0, then fx times gx greater than 0. Similarly, if fx less than 0, gx greater than 0, this also applies to vice versa, or vice versa, meaning gx less than 0 and fx greater than 0, then fx times gx is going to be less than 0. So that's going to be above the x-axis, that's going to be below the x-axis. These are pretty much the standard rules for curve sketching multiplications. Okay, take a screenshot, take a photo, whatever you need. That's how we multiply graphs together. Let's move on to the next section. Alright, so we're given this graph. The diagram to the right shows the graphs of y equals fx, where fx equals x squared, and of y equals gx, where gx equals x. So that's telling us what they are. This is fx, the curve, is fx equals x squared, and the straight line is gx equals to x. So copy the diagram into your book, so we should be drawing that graph. All right, just like that. All right, there we go. On the same set of axes and in different colors, sketch y equals fx plus gx by adding ordinates. So what we're going to do, I can see that the intercept here is meant to be 1, so I'll take some liberties with that. I'll say that that's 1. Maybe I can enlarge it to match it up. I'll try and enlarge it in such a way that it lines up with that. Oh no, it doesn't want to do that. Maybe I'll shrink the graph. Alright, my apologies guys, I just, you know how it is for me. Alright, so that there is 1. We'll just put an arbitrary 2 there. We're using like every 3 grids. -1, -2. And from that perspective, that's also at 1, 2, 3. -1, -2, -3. Alright, that'll do. Alright, now on the same set of axes and in different colors, sketch y equals to fx. Alright, on the same set of axes and in different colors, sketch y equals fx plus gx by adding the ordinates. Alright, so again, let's start with the easiest points. We can see here we have +1 and -1. If I add 1 and -1, that's going to give me 0. We have here 0 plus 0. So I can probably take a guess we're going to have this thing happening again. Here we have 1 plus 1, which gives us 2. And then over here, it just looks like it's getting bigger and bigger. Now I'll take an educated guess by mirroring that result. And that's plenty right there. There we go. I think it's a bit wrong. Alright, it's definitely the green one. And there we go. Alright, let's see if yep, there's one more. So look at this. Sketch graphs of y equals x squared and y equals absolute value of x minus 1 on the same set of axes. Hence, sketch the graph produced by y equals to x squared times x minus 1. I'm just going to lower this because I don't think there's any negatives for this graph. Firstly, let's sketch the parabola. Actually, I want to sketch the absolute value. So that's y equals absolute value of x minus 1. And now the parabola y equals to x squared. Alright, it's a bit strange drawing on a parabola like this to perfection. But let's see how we go. Now look at this. Hence, graph the product y equals to x squared minus 1. So real quick, we know that's 1. That's what it is. That can't be 1 unless I make the graph bigger. Doesn't seem to be working. Alright, what I'm supposed to do, I need to create a parabola that goes through these 2 points. Alright, there we go. That took a while, but I think that's it. So now I'm going to multiply these 2 graphs for part B. So that's part A done. Part B asks us to sketch y equals x squared bracket absolute value x minus 1. So on the same set of axes, using the properties I just learnt, It's kind of hard to tell where these intersect, but all I know is that's going to be definitely above here because we have positive times positive. We're going to be creating big numbers. Okay, so let's start with this. This looks like to be 1 times 2. So 1 times 2 is 2. So that's going to be a dot right there. We have here 1 times 0. That's definitely going to be 0. Well, I should label it just a tad. All right, and then from there we have 0 times 1. So we have 0 here. And then from there we have positive times positive. So we end up with 1 times whatever that is. So it's definitely going to be up there as well. Okay, so the way we sketch this now, I think it goes below and then there. Okay, so now to sketch this, we know that this just continues on very quickly, especially after the value of 1. So once y value goes beyond 1, we start accelerating the graph really fast. And that's that. Now explain why your graph of x squared times x minus 1 lies below both graphs, y equals x squared and y equals x minus 1 in the interval 0 to 1. Alright, explanation is rather easy. That is because between 0 and negative 1, oh, whoops, I made a mistake here. See this section right here? This doesn't exist. And it's thanks to that absolute value. Why? Because everything here is positive. Meaning, we're going to either get a smooth or a bump like this. Just like that. Okay? Why? Because you can see the blue lines are positive. There's no need for any graph to be negative. Both graphs, in fact, are completely above the x-axis, with the exception of the 0 intercepts. And that's all we need to cater to this. But apart from that, that is the full sketch of that interval. And between 0 and 1, we can say that the graph is going to be above the x-axis, but it should be technically below the graph. And why is that? Because you have a fraction times a fraction in that region. So a fraction times a fraction, if you take notice, it gets quite small. All right. And we can leave it at that for the time being. Actually, there's a multiplication here as well. So the techniques of sketching the product of two graph functions extends readily to sketching a square. So this is a bit of an investigation question. So we're going to sketch the square of y equals fx, because fx squared is basically fx times fx. So in some sense, you're just sketching the graph against itself. Let's sketch this by plotting all the points in. We have 0, we have 1, and we have, we have 2, which is all the way here. All right, that should be the graph. I was able to do that so quickly because x equals 0, x equals 1, x equals 2. If you recall, those are the three solutions. So 0, 1, and 2. And it wants us to sketch the square of fx squared when we have 0 less than x less than 2. All right, so now let's have a look. Basically, the question wants us to do this blue graph multiplied by itself. So that can be somewhat easy. First things first, if I multiply this region here by itself, I'm going to end up with less value. Why? Because a fraction times a fraction that is less than 1 produces a worse value or a smaller value, depending on what kind of context you're thinking in. So here we have 1 times 1 times 1, we're multiplying by itself. So 1 times 1, and suppose that is 1, that gets to stay there because 1 times 1 is 1. The next easy part, 0 times 0. 0 times 0 is 0 already. Alright, the next one, we have 0 times 0. And 0 times 0 is 0. But now we have this, negative 1 times negative 1. Well, if we recall, negative 1 times negative 1 is actually positive 1. And then finally here, 0 times 0, which gives us 0. And then from there, if that shoots up and that shoots down, then for this part here, it's going to shoot up real fast. All right, so now we connect the dots. Now you probably wonder why I didn't do that. Well, if you look, that's above the x-axis and it's squared, so it can't. All right, so sketch the function, then sketch the square y equals fx squared. So I've already done that. And it says for 0 less than x less than 2. So that means I was only supposed to sketch this green part that I'm doing now. And that's that. That green part there is the answer that the question wanted. If you had any issues with it, just go back and try it again yourselves. Let me do one more neater sketch. And there we go. Alright guys, good luck with that. Try your best.